Now to news of what sounds like a significant step forward in the area of stem cell research. It involves the treatment of an eye condition called age-related macular degeneration. And the way it's done is to grow special cells which are then grafted onto the patient's retina.
That retinal graft is usually obtained from stem cells grown from human embryos. Now, the new development is that for the first time, doctors have been able to use cells that come not from embryos, but from the patient's own body.
Well, to tell us more, we're joined by Peter Kofi, Director of the London Project to Cure Blindness and Co-Director of the Centre for Stem Cell Biology and Engineering, the University of California, Santa Barbara. We've tried to sort of sum up in our own layman's words what this is all about. Just talk us through the process here.
So age-related macular degeneration is a disease which affects people over the age of 65 and the largest population over about 70. And what happens is people go blind as a result of the disease, which is a fault at the back of the eye, which affects their high acuity vision, so the vision that you use for driving, recognizing your loved ones and being able to read.
And this can be treated with these stem cells, where usually you rely on stem cells obtained from embryos, but here it was a little bit different.
Yeah, so the disease itself can't be treated at the moment with any conventional methods, i.e. drugs or pharmaceuticals. But one way may be to replace the cells which are affected by the disease, because those cells start to deteriorate and die. So the advantage here is that actually the patient themselves is the source of their own therapy. So what we can do, or what the group in Japan has done, is actually taken a sample of their skin, turned that skin back into a stem cell, and then turned the stem cell into the eye cell that's affected in the age-related macular degeneration.
And I would guess one potential benefit is that limits the risks of this sort of graft of cells being rejected by the patient's body, because it comes from the patient's body.
Absolutely, and that's the major benefit, is that actually with any other type of cell which is taken either from an embryonic source or from anyone else, would potentially have a problem in terms of being rejected due to the mismatch in the immune system, whereas obviously coming from the patient and going back into the patient, that would not be the concern.
For someone like yourself involved in this sort of work, I mean, how exciting does this look?
It's very exciting. I mean, to be able to take cells and actually replace disease cells in the body, it's just bringing a new concept to medicine. So no longer are you maintaining the person at the state they are when they visit their doctor with the disease. The whole possibility of rejuvenating that person is immensely powerful. And the UK Regenerative Medicine Platform in the UK is actually funding the London Project to do a very similar trial in the UK. So it's very exciting.
Oh, exciting times indeed. Peter Kofi, many thanks.